Okay, let's look at the section 4.4, number 65. So this is an example of 1 to the infinity case for L'Hopital's rule. Right, so let's check that. Right, so first thing we plug in. So cosine of 0 is 1. So this guy goes to 1. Right, 1 over 0 from the positive side. So this guy goes to positive infinity. Right, so we have 1 to the infinity form. Right, so this is a hidden L'Hopital's rule problem. Right, so we have to create a fraction so that we can apply L'Hopital's rule. Right, here's how you simplify this. Right, so we have we're going to observe that cosine of x to the 1 over x squared can be rewritten as e to the natural log of cosine of x to the 1 over x squared power. Right? Remember that the exponential function and a log function are inverses of each other, so we can cancel out to go back to this. Right? So these are exactly the same. Right? To make it a little bit nicer, we actually use the property of log. If you have a power here, we can actually put this power in front, right? So you're going to get e to the, right? So 1 over x squared. So I'm going to actually write it this way, like a fraction, so that it looks more like a L'Hopital's rule. So a natural log of cosine of x divided by, it's 1 over x, so it's x squared, right? So we have that. So this is equivalent to the original expression. So in order to take the limit, I'm going to go ahead and take the limit of this guy, right? So let's look at the limit. So we're going to take the limit as x approaches 0 from the positive side of natural log of cosine of x over x squared, right? So you can see that if you plug in, so denominator obviously goes to 0, right? Cosine of 0 is 1, but the natural log of 1 is 0 as well, so the top goes to 0, right? So now we can apply L'Hopital's rule. So L'Hopital's rule, right? So you still have the limit as x approaches 0 from the positive side, right? Then if you take the derivative of the top, you're going to get the cosine of x on the bottom. And take the derivative of that, put it on top, so that will be negative sine of x. And derivative of x squared would be 2x, right? So we have that. And clean up a little bit, so it's going to be a limit as x approaches 0 from the positive side. Right, sine over cosine is tangent, so I'm going to write as negative tangent of x over 2x. Alright, then plug in. Alright, so denominator 2x, as x approaches 0, of course denominator still goes to 0. Alright, and unfortunately tangent of 0 is 0 too, so the numerator still goes to 0. Right? So 0 over 0, so we can apply L'Hopital's rule again. So I'm going to go down here. So the second application of L'Hopital's rule. Right? So we still have limit as x approaches 0 from the positive side. Right? Take the derivative of negative tangent, so it's going to be negative secant squared of x, and a derivative of 2x would be just 2. right? All right, so this one is easy to evaluate because the secant of 0 is, secant is a reciprocal of cosine. So cosine of 0 is 1. So reciprocal of 1 is still 1. So it's 1 squared minus, so it's going to be just negative 1 on top over 2. All right? All right, so this is a limit. So this power approaches 1/2. Actually, sorry, negative 1/2. So therefore, the original limit approaches. Remember that only the power goes to negative 1/2, so it's going to be e to the negative 1/2. So e to the negative 1/2 would be the limit of the original problem. All right, that's it. I hope that this was clear.